A very warm welcome. This is Debduhita Banerjee, 20 BC 1429, and my topic for digital assignment 1 is blockchain trilemma. So, blockchains can only handle a limited number of transactions per second. The Bitcoin network, for example, can process around 7 transactions per second. If blockchain technology is to be adopted globally, it should be able to handle increasing data and at faster speeds so that more people can use the network without it becoming too slow or too expensive to use. However, the fundamental design of many decentralized networks means that increasing scalability tends to weaken decentralization or security. This is what is known as the blockchain trilemma. Developers are looking to solve this problem, are experimenting with different consensus mechanisms and scalability solutions. We'll be delving more into the important topics of decentralization, scalability, and security shortly. So we can think of the blockchain trilemma problem as a triangle with each of the vertices representing each of the fundamentals of scalability, security, and decentralization, where we cannot choose all three at once. So coming to the blockchain structure, a blockchain is a distributed digital database. Blocks are organized in chronological order. The blocks are linked and secured by cryptographic proof. The implementation of this technology across different industries is already changing how we work and live. So, coming to the decentralization aspect of the blockchain trilemma, the term decentralization in general talks about how control is shifted from one central unity, company, or government and is split across smaller groups to govern something. In blockchain, decentralization gives power to people across the world to govern their computer nodes rather than having a central control of the network with any person or party. The blockchain networks are decentralized by design. The whole structure is such that no single person or organization would be in charge. The network layer would be open to anyone who wants to participate. As a result, control is fully distributed rather than held by one single entity. Everyone has access to the same data. If anyone tries to cheat the system by changing the records in their favor, then the rest of the participants will reject the faulty data. However, because of how these distributed systems work, with the need for wide range of participants to agree on the validity of any data, transaction times can be slow due to the way information needs to be shared and processed. So blockchains need to scale, which is to say that it needs to be capable of handling more data at faster speed. Additionally, the decentralized dream only holds true if the underlying blockchains are secure. If blockchain lacks security, then a bad entity can take control and change the data in their favor. This leads us to the second part of the trilemma, that is security. Coming to security, it doesn't matter how decentralized a blockchain is if it lacks security. A good blockchain network should be resistant to attacks from malicious entities. Centralized systems derive the security from the fact that the system is closed. However, who is in control can guarantee the data is free from interference. But how is this to be achieved in a decentralized system where anyone can take part? The blockchain system uses a combination of cryptography and a network consensus mechanism called proof of work. In terms of cryptology, each block has a kind of digital signature or hash. Each block of data is connected in a way that cannot be tampered with because any changes would alter a block's hash. Any attempt to change the data would be quickly identified by the rest of the network. So the proof of work consensus mechanism helps secure the cryptocurrency's ledger. Blockchain is inherently secure but not entirely immune to hacking. If a hacker is able to secure control of more than half of the network, that is, to be precise, 51%, they would be able to alter a blockchain and manipulate transactions to steal from the network. Then they would be able to override the consensus and change the chain's data to benefit themselves. So, in blockchain, the more the number of nodes, the more the security. In short, we can say that security is a fundamental requirement for blockchain to be successful because without it, attackers can take control of the chain, rendering it useless. Now, coming to scalability, scalability refers to the goal of building a blockchain that can support more and more transactions per second. Scale is required if blockchain technology is to serve wider society and possibly billions of users. But this is where a lot of blockchains will struggle. This is because decentralization and security are so fundamental to blockchain that they tend to be focused on first. Decentralization is central to ethos and goals of blockchain, so it must be addressed to first. And security, as we have already discussed, is a core requirement for blockchain to be successful and useful. However, by prioritizing decentralization and security, scalability can become a challenge. The number of transactions a chain can handle can be severely limited, and a centralized system payments such as Visa is able to support 24,000 transactions per second. This is only because the network is closed and not decentralized. So, why does the blockchain trilemma exist? We know now. So, we have to look for solutions. So, the most obvious and basic solution that comes to our mind is to reduce the number of participants, confirming and adding to the network data in exchange for greater scale and speed. But doing so would lead to weakening of decentralization process with control handed to a smaller number of participants. And it would also lead to weakening of security as fewer players means a higher chance of attacks. If more and more people in society begin to use blockchain technology, the networks will become so jammed due to the limited number of transactions they can handle. So, we can say that there is no one golden solution to the trilemma. But given the importance of solving this problem, there have been a number of different approaches within the community with interesting results. Number one is sharding. Sharding is a method of splitting the blockchains into smaller, partitioned blockchains that manage specific data segments. This setup takes the stress off a single chain dealing with all transactions and interactions on a network. Each partitioned blockchain is known as a shard and has its specific ledger. These shards can then process their own transactions, but a beacon blockchain or main chain manages interactions between shards. This makes sharding a layer 1 network scalability upgrade as it's a change to the mainnet of a blockchain. Method 2 is using different consensus mechanisms. One of the reasons the trilemma exists is because of the way the proof of work works to ensure security. The need for miners, crypto algorithms, and huge amounts of decentralized power computing leads to a secure system, but a slow one. Finding different ways to secure consensus is one approach to solving the trilemma. This is one of the reasons behind Ethereum's move from proof of work to proof of stake or POS. In POS blockchain system, participants involved in validating transactions must stake lock their tokens. There's no need for highly specialized mining machines. Adding more validators to the network is simpler and more accessible. POS is just one of the many approaches to consensus mechanisms with scalability in mind. Number three is layer two solutions. Both sharding and different consensus mechanisms, what we have already discussed, are known as layer one solutions. They look to change the fundamental design of the underlying network. But other developers seeking to solve the trilemma have been working on solutions that build on top of an existing network structure. In other words, they think the answer lies in a second layer or layer two. The examples of this system consist of side chains and state channels. A side chain is basically a separate blockchain connected to the main chain. It's set up in such a way that assets can flow freely between the two. Importantly, the sidechain can operate under different rules, allowing for greater speed and scale. Similarly, state channels are another way of taking transactions off the main chain and easing pressure on layer 1. A state channel uses a smart contract rather than a separate chain to enable users to interact with each other without publishing their transactions to the blockchain. The blockchain only records the start and end of the channel. So, coming to the closing thoughts, the scalability trilemma can stand in the way of a blockchain fulfilling its full potential as a technology to change the world. If blockchain networks can handle only small number of transactions per second in order to maintain decentralization and security, then it will be difficult to reach mass adoption. However, the solutions currently put forward by developers seeking to solve this problem suggest that the technological advances already made by blockchain will only continue, and these networks may as well be the handle much more data in the future. So here we come to the end of the presentation. Thank you.